Okay, today what I want to do is look at just a few problems evaluating limits algebraically. So we're just going to have a few examples. So we're just going to have a few examples of a particular type where we can do these algebraically. So to get started with this, the first thing I want to do is just notice what happens if I plug 0 into this thing. So let's see, what we would have is 4. Now if I plug the 0 in for x here, this is going to give me 7 squared minus 196. We're going to have 0 here. And then if we multiply out this numerator, we're going to have 49 times 4. That's actually 196. So 196 minus 196, we have this 0 over 0 situation, which we call an indeterminate form. So what's the limit in this case? Well, the indeterminate form means that we don't know yet. We're going to need to do some more work, and that's why we need to do some algebra on this. So what I'm actually going to do is, rather than plug in, let's actually multiply this out. We'll square this out, actually. So this is going to be 4. Then multiplying this all the way out, we're going to have 25x squared. We're going to have plus 70x plus 49 minus 196. We'll keep our x here. Now when we distribute the 4 in, we're going to end up with 100x squared, 280x plus 196 minus 196 over x. The 196 terms are going to cancel. I can actually factor an x out of this, right? So we're going to end up in our numerator, we're going to have x times 100x plus 280. And we still have this x in the denominator. Well, now we can cancel an x. That's exactly what we want, right? Because we were dividing by 0, and that's the key to these whole things. When we're dividing by 0, we usually have a problem. It can be okay in some cases because it could evaluate to infinity. But in this case, because it was indeterminate, we need to cancel that off. So now what we can do is evaluate this at 0. And when we do that, we plug a 0 in here, we get 0. And so we're going to just end up with our limit, which is going to actually be 280. Good. Now let's look at another example. Okay, next we have the limit as x approaches minus 1 of x plus 1 over x squared plus 10x plus 9. We plug a minus 1 in here just to see what's happening. That's going to give me a 0 in the numerator. And then again, we plug minus 1 in the denominator. We're going to have 1 minus 10 minus 9 plus 9. We have 0 over 0 again. So again, indeterminate form, we're going to do something similar to what we did last time, but now we can factor right away. So we have our x plus 1 here. I'm going to factor this. This is going to actually factor as x plus 9 times x plus 1. And that's pretty nice because we can cancel our x plus 1s, right? And that's going to give me just 1 over x plus 9. And now what we can do is now let's evaluate it at minus 1 and see what happens. We plug this in. In the denominator, we're going to have minus 1 plus 9 is an 8. So we're going to end up with just our limit of 1 over 8. I think I have space. Let's just do another one right down here on the bottom half of the board. Okay, so this one's actually going to be really similar to the one we just did, I think. And then I'll let you validate, but if you plug in 10 here, you're going to end up with 0 over 0, indeterminate situation again. So we're going to need to do some factoring, and let's just factor this thing. So in the numerator, this is going to be, what is this going to be? X minus 10 times x plus 9. And then here in the denominator, this is going to be x minus 10, and then we're going to have an x minus 4 here. Oh, and I need to squeeze in my limit thing right here, sorry. So then we'll go ahead, we'll cancel our x to the minus 10s. That's pretty nice. So now we're not dividing by 0 again. This is going to help. So then we'll plug in, let's evaluate it at 10. We're going to end up plugging in 10 here. We're going to have 19 in the numerator and 6 in the denominator. And that's just going to give me a limit of 19 over 6. Okay, now this one's interesting. It's actually similar to before. We want to factor this. But first, let's plug in our 1. And we notice we're going to end up again with 0 in the numerator. You plug the 1 into the denominator. This is going to be 0. So this is going to be 0 over 0, indeterminate form. Now what we need to do is we need to factor this denominator to see if we can get some cancellation. What I'm going to do for this, let's just make a substitution. Let's kind of say, but it's going to help us with our factoring. We're used to factoring quadratics, and we've got this square root of x. It's just a little awkward if you're not used to it. So let's call our square root of x equal to t. So then t squared is going to be x. So then making the substitution on this, we can write this as t squared minus 8t plus 7. And then I think the factoring is apparent then, so then we can write this as t minus 1 times t minus 7, factoring this. But then now let's back substitute what we did. So t minus 1, this is going to be the same thing as square root of x minus 1 times square root of x minus 7. So now let's just rewrite this all factored out. But now we get the cancellation we need here. And so we're going to end up with this as just 1 over square root of x minus 7. Now you can see with the 1 in the numerator, it's no longer an indeterminate form. Let's evaluate it at 1, and this is going to give me 1 over square root of 1 is 1, minus 7, so minus 6. This is going to be the limit's going to just be minus 1 over 6. Okay, now last problem, doing the same thing. We're going to plug in a 1, see what's happening at 1. So we're going to have 0 in the numerator, again, 0 in the denominator, indeterminate form. I know they're all indeterminate form, so I kind of package these together because they're all really similar. So now what we're going to do is, I don't have really a great way to factor this, so what I'm going to do instead is, let's just multiply by the conjugate of this denominator, so I can multiply it by x plus square root of 2 minus x, and do the same thing here in the numerator. Let's distribute out the denominator. The nice thing here, it's the difference of two squares. That's what happens with a conjugate. So we end up with x squared minus 2 minus x. I'm going to distribute in the minus, so it's going to be like minus 2 plus x. Now for the numerator, you might want to distribute this. It's actually going to work better if we don't. So with these limit problems, it's kind of a good idea to not distribute that in, just leave it like this. And then from here, what I can do now, I can factor this thing. This thing's actually going to factor as x plus 2 times x minus 1. I know it's a little awkward because we're not used to that order, but if you multiply that out, you'll get back to this. And then let's just rewrite the numerator here. But now at this point, we get the cancellation we were looking for. And now let's try to evaluate it at 1. So if we plug this in, we're going to have in the numerator, we're going to have 1 plus square root of 2 minus 1. And then here in the denominator, we're going to have 1 plus 2, or 3. 2 minus 1 square root of 1, this is going to be just 2 in the numerator over 3. And so this limit's going to be 2/3. Okay, in the next video, we'll be doing some more limits, but just some different looking functions with some different looking methods. So we'll stop it there. Thanks everyone for watching. Have a great day.